Hello everyone. In this video, I will demonstrate how to perform factorial Manova. Specifically, we will be performing two-way Manova here. So this is the example we're going to consider for this video. So let's say we are interested in determining the degree to which gender and job satisfaction affect income and years of education among employees. So here, if you see, we have two independent variable, which is sex and set job. So sex is categorical with two labels, male and female, and set job is also categorical with four labels. Very satisfied, moderately satisfied, a little satisfied, and very dissatisfied. So these two are independent variables. And we have two dependent variables. One is R income 91 and education, years of education. So they both are dependent and they both are interval or scale level variable. So these are the research questions here. Do income and years of education differ by gender among employees? Do income and years of education differ by job satisfaction among employees? And do gender and job satisfaction interact in the effect on income and years of education? So here we're going to be testing some interaction effect here. So in this video, I will mainly talk about the assumptions. We're going to talk about the missing values. We'll talk about the outliers. We'll talk about the sample size here. We're going to talk about the normality, which basically says that observations on all dependent variables must follow a multivariate normal distribution in each group or cell. So how many group and cells are present here? So if you see here, we have four labels in job satisfaction and two labels in sex. So we have 4 times 2, which is 8. So we have 8 groups or cells available. So we want to divide the data among those 8 cells and check the multivariate normality. So as you may know that, multivariate normality is difficult to assess, but we'll discuss some of the techniques you can use, like bivariate scatter plot to assess the multivariate normality, and univariate normality could be tested using, QQ plot, or normality test we have, or histogram. So we're going to talk about that. Then we'll also talk about linearity, the relationship among all pairs of dependent variables for each cell. Again, we have 8 groups or 8 cells in the data matrix must be linear. So again, the best way to assess the linearity is through bivariate scatter plot. And again, keep in mind that bivariate scatter plots are extremely subjective. Okay, so that's something here to keep in mind. But it gives you 10,000 foot view of the assumption whether it satisfies or not. So we're going to talk about that. And the last assumption is homogeneity of covariance matrices. This is tested while running Manova. So we're not going to talk about in this video, but maybe in the next video here. Now, this material I'm taking from this book here, Mutler and Venata, Advanced in Multivariate Statistical Methods. Very good book. I would insist that you should refer to this book, and I'll be referring to this book as well in this video lecture. So let's get started. First thing first, I would go to my data set here, and that's my data set here, and I will go to the variable view here and check my variables. So we have education. So if you see here, education is a dependent variable, and these are 97, 98, 99. These are being considered missing values anyway, so it's not going to affect us as such. So the next one is a sex, which is 1 is male and 2 is female here. Then we have job set or set job here, and it has 0, 1, 2, 3, 4, 8, and 9. So if you see 0 and 8 and 9, they are not applicable here, but they already been treated as a missing value, so we don't need to worry about that here. Okay, so that's a side job. So and then we have our income 91, which is dependent variable and which is scale level. So our degree, I'm sorry, the sex was nominal, categorical, uh, and our side job was ordinal, which is again categorical, but it's ordinal level. Okay, so but our education was scale or interval scale, and R income 91 is also scale level. But if you see the data here, it is actually category. So you see it's ordinal, but it has too many categories. So it's being treated as interval scale or scale level variable, and this is often the case with the Likert scale as well. Whenever you collect the surveys using 5-point or 7-point Likert scale, basically that's an ordinal data, but we always treat them as a scale level variable and do the statistical analysis. So here also it's been done like that. But here you need to see that anything about 21, so 22, 20, 98, and 99, they are not applicable. So we need to remove this one and treat them as a missing values here, because otherwise they will be misunderstood as different categories, and we don't want to do that. So we're going to go ahead and remove that one and treat them as a missing values. And not only that, but the 0 is also not a category, so we need to treat this one as a missing values as well. So that's the first thing we're going to do while analyzing our missing values. So I'm going to go to the data view. I will go to the transform, recoding to different variables here. So we're gonna do the transformation for our hold on, R income 91, right? So I'm gonna do the transform, recording different values, R income. This is the one. I'm gonna record this to R income 2 here. So we're gonna say the highest, so 22 and up should be treated as a missing value, and lowest through 0 should be treated as a missing value. All other values should be copied as is. Okay, so once you are done with this one, continue and say okay here. It's going to go ahead and create another variable for us here. Okay, so we can sort this ascending. So this looks all right here. Sort descending, it again looks all right here. So we have created that one. So this is the way you should be treating the missing values. Missing values are not only just looking at the values which are missing, but also the existing values, if they make any sense. If not, we have to treat them as the missing values, or maybe transform the variable. So once done with the missing value, the next logical step is to deal with the outliers. So what we're gonna do here is to check the outliers, which could be best done using a stem and leaf plot or box plot, right? Or some researchers also use Mahalanobis distance, because we have more than one dependent variable. So I'm gonna kind of discuss all these things, and then we'll go as per the book describes it. Okay, but I'm gonna tell you the best way to do it here. So let's go ahead and do that here. So first thing, we have 8 groups or cells. I want to split the data across 8 equal groups. So we're gonna go to the data split file here, compare means, and I'm gonna split it across respondent sex here and job satisfaction. Okay, and I'm gonna say okay here. So it's gonna split the file and create 8 different groups. Now I'll go ahead and do the we can go here, doesn't matter, analyze, descriptive statistics, explore here. Okay, I want to explore my or income 2 and education. So this one there. Okay, and we already split the file, so we don't need to mention the factor list here. Statistics, we just want descriptives here. Plot, at this point I'm just looking at the outliers. Okay, so I'm just going to do the box plot and the stem and leaf chart. Okay, so options, make sure this is selected, so it's going to exclude all the cases list-wise. So wherever you have cases where 1 or 2 values are missing, those will be excluded from the explore. Continue this one here, say okay here. So our focus here is on the outliers. So I'm just gonna straight jump to, let's say, we're gonna discuss about the education, but you have to do it for income as well. So here, if you look at the stem and leaf graph here, you can browse through all the 8 one here. So here you have some missing values here. So less than equal to 12. There are 3 values like that here, or 3 here, greater than equal to 18. Then here you have 1, which is less than 0. So you have to basically browse through all of them. Okay. So likewise, the box chart also gives you pretty nice detail about the missing values. So for example, for sex equals male and side job equals very dissatisfied. For education, usually a lot of outliers on here. Okay, so we need to take care of this thing here before we move on. So basically, if you see here, there are some outliers here, like it's 0, almost 0. So it's very rare that you will have somebody with the education equals 0 years. So what we can do here is, if you go back to the data and sort the education ascending, you see you have some 0 and 6 years of education. So it's better to basically eliminate anything equal to less than equal to 6. So what we're gonna do here is we're gonna transform this one, and we're gonna recode this into different value. So before doing that, I want to tell you that how the book is doing it. So basically, what we're gonna do here is we're gonna switch off the split file command here. So I'm gonna select all the cases here, so that split file is off now. Now how the book is doing it, book says that you go to analyze, descriptive statistics, explore here, and here we have to mention the factorial list here. So we have respondent sex here and job satisfaction here. The rest of the things are being same. We're not going to change anything here. Plot are the same here, and we're going to say okay here. Now here, if you see, for example, education box plot here, right? So here we are only creating for each label for each independent variables. For example, this is the job satisfaction has 4 labels, so we're going to create 4 box plots here. Looks okay, but it looks like there are some outliers here. And likewise, we have sex as well. So we're going to see education box plot here. So it shows you some outlier here, but it's in all creating 2 + 4, 6 box plots. While earlier we saw here 8 box plots. Okay, so so book says this as well, but basically all the assumptions that you have seen in Manova, they are for every cell or for every group you create. So the number of groups equals to number of labels in each the independent variable times number of labels in all other independent variables. So here we have 8 groups or cells. So this is something you have to keep in mind while performing the analysis. I'm going to go ahead and transform. I'm going to make sure that split file is off. It's already off here. Okay, and I want to go ahead and transform that education and create education 2 here, and I'm gonna say so we're gonna say lowest value through 6, treat them as a missing value. Okay, I'm gonna take this one out, I'm gonna take this one out. So lowest through 6 as is missing, else copy. So we're gonna go ahead and do that. Okay, so it will go ahead and create another one variable here, education 2, and descending they looks all the right values here. So anything less than equal to 6 being omitted here, so they will be treated as a missing values. So once we are done with the outlier analysis, the next logical step is performing the sample size for, or evaluating the sample size for each cell. But before we go there, let's talk more about the outliers. I have seen people or researcher creating Mahalanobis distance as well to check the outlier, because we have more than one dependent variable. So I'm just going to show you the process, how it's done. For example, here we'll go to analyze here, and we go to linear regression, linear here. Since we are calculating the Mahalanobis distance, dependent variable does not have any sense. So we're just going to create ID, treat ID as a dependent variable, and we're going to use our two independent variables. So I'm going to say R income 2 and education, original one, which was not transformed. Okay, so we don't want any statistics here. Continue here, plots. I don't want any plots. Save, we want to save Mahalanobis distance here. So options, so okay, is going to exclude the cases list wise. So if you have any case where you have 1 or 2 values missing, it will be ignored from the analysis. So continue that one. I'm going to say okay here. So it's going to create the Mahalanobis analysis here. The main thing you have to look here is the maximum value here. Okay, that is 27 here. So what we have to do is anything above 27 should be treated as a missing value, or should be treated as an outlier. So what we can do here is we can look up the critical value. We don't know the critical value here. This is the maximum you have in the data set. So if you go back to the data set here, so if you sort in descending, so the maximum was 27. So clearly this looks like an outlier, but we need to check this against the critical value. So the critical value here is we're gonna have the p-value less than 0.001. So that's a critical value we're gonna worry about. So again, p-value should be less than equal to if the p-value is less than equal to 0.001, it is significant, and those should be eliminated from the analysis. So let's go ahead and create another column for the probabilities here. So I'm going to say transform compute variable. This I'm going to say probability MD for Mahalanobis distance here, 1 minus, say this one, CDF chi-square, and obviously here we're going to have the Mahalanobis distance that we just calculated, and degree of freedom should be equal to the number of dependent variables you have, which in this case we have 2. So we're going to say okay here. So if you go back to data here, it's going to create this one. So anything that is less than 0.001, so all this value should be treated as outliers. So that's another way I've seen researchers finding out the outliers in Manova. So this is another way, but we're just gonna stick to our analysis so far. Which we have already transformed our education into education 2 by ignoring all the cases where you have education less than equal to 6 years. So we're going to stick to that. So once we are done with the missing value and the outlier, the next thing we should check is the sample size for each group or cell, and the normality test. So let's go ahead and do that now. So we're going to go to the, let's say, I'm going to split the file again because I want to create those 8 groups here. So I'm going to compare the groups, job satisfaction, sex here. So once we created the groups or split the file across 8 different groups, we will go ahead and do the analyze here. Descriptive statistics and explore. Okay, we're going to take out this factor list here because we already did the split. We want the transform variable here, not the original one. So we're going to go with the education 2 statistics. This time we want descriptive plots. Now we have to get the normality plot and test with test as well, because we want to make sure that the normality assumption is also taken care of for each group. So we're going to do that. We're going to discuss more about that. So we're going to continue here. Options, it's going to exclude all the cases list-wise, meaning that if there are any missing values, in any case, those cases will be ignored from the analysis. So continue here. We're going to say OK here. And just going to minimize what I don't need here. This is the summary here. So here we can see how big are the sample sizes for each group. So here we see that sample size in some group are as high as 167, 166, and as low as 10. In some of the cells we only have groups, we only have 10, which is very low. Now, how big should be the sample size for each group? It should be logically, bare minimum 20. But some book like Hair and Black book suggests that it should be, if you refer to Joe Hair and Black book, this is that it should be at least 30 per cell, because if you have lesser than that, then it could be difficult to achieve the statistical power. That something you have to keep in mind. But bare minimum, it's been said in the literature that you gotta have 20, or there is another formula, like it says that the number of the sample size should be equals to the total number of groups times the number of dependent variable. So in this case, we have 8 groups and 2 dependent variables, so 16. But still, even as per that criteria, we have some groups where we have lot lesser. So sample size plays very important role. If the sample size are too small, that's a problem. You don't get the statistical power or desired statistical power. Or if the sample sizes are too huge, that's a problem as well, because if if the sample size in each group, let's say, is over 400 or 500, then even a small difference could be between the groups could be termed as significant. So that needs to you needs to be aware of that as well. So the group sizes here are very uneven. Some have lots, some have very few, and that could have some impact on the normality test as well as the significance test as well. That's one thing. Now we're gonna go back and test the normality here. So these are the results here. If it is significant, that means this is not normal. So we have to do across each group. So we have 8 groups here. If you see here, male is for every male we have 4 categories across 2 dependent variable. So you can see that here most of them are not normal. All the zeros anything greater than 0.05, which means that it's normal. So this is a KM test or Shapiro-Wilk test. Usually I prefer KS test, but you know, it all depends on your, as such, you know, research preferences or your domain expertise, I would say. So here, you know, you can check some of them. For example, let's check whether it says that the male who are a little dissatisfied, they are normal for both. So we can check this one using the box plot. So let's see the male, a little dissatisfied, box plot. Okay. So let's say the education 2. So we have a male here, right? Male a little dissatisfied, right? So that should be this one, right? So if you see that it's very symmetric box plot, so that's an indication that, you know, it's very normal. You can also see the QQ plot for the same. So male a little dissatisfied, not normal QQ, but I would rather do the QQ plot here. Now, so all the points are nicely falling across this diagonal line, which indicates it's a pretty much normal distribution. So that's how you should perform the normality test. It should be performed again across each group. Again, here a lot of them are not normal, and you have to keep in mind that unequal group sizes coupled with all this not normal or not normality could create a problem when we assess the you know homogeneity of variance and covariance assumption. It may not be significant because we have uneven sample sizes and a lot of distributions are not normal. But Manova is very robust to the violation of normality distribution assumption. So we're gonna still go ahead and perform the analysis. So this is how I would prefer. Now let's see how the book does it. So I'm gonna split file. I'm gonna put this command off. So I'm gonna unsplit the file here, and then we go to the analyze, descriptive statistics, explore. In the factor list, we're gonna put our respondent sex and job satisfaction here. The rest is gonna be all same. So here so here we go to the normality test here. I'm just gonna go to the test of normality here, test of normality here for the sex here. So we're gonna go here and see all are significant. So this is how some researchers do it. They're not doing for every cell, but they're doing for every label for each independent variable. So we're gonna do here twice for male and female, and 4 times here for the job satisfaction label category. But you know, logically you should be doing for each and every cell like I demonstrated earlier. But the results are pretty much the same. You know, here you see that most of them are not normal, some of them are normal. So our income very dissatisfied, or even education too very dissatisfied, they are normal. And if you see the cases here, we are 24, and that's the reason you would like to, you know, do it at a you know lesser number of labels, because when you do it at the lesser number of labels, like here we have only 6 labels at which we are checking our normality, you increase the cell sizes, you know, and that could be one of the reasons they are doing it. I've seen people just testing the normality by itself, not across any labels. So Black and Hare book does that. So that's something you have to keep in mind. It always depends on, I guess, the sample size and your preference. But the assumption says that the normality or outlier should be tested for each cell or each group. Now, what we have tested is a univariate normality. The assumption says that any linear combination of the dependent variable should also be multi-normal across all the groups. So we're not just talking about each individual dependent variable individually, but when you combine them, they still should follow a normal distribution, which we call multivariate normal distribution for each group. Now, there is no easy way to test the multivariate normal distribution form. So the best way to do that is by creating a scatter plot. Okay. So if the scatter plot is pretty elliptical, we can say that it follows the bivariate normal distribution. Scatter plot can also be used to test another assumption for our analysis, which is linearity. So it says that the relationship among all the pair of dependent variables for each cell in the data matrix must be linear. Okay, so it can be assessed using bivariate scatter plot. That's what we're gonna do. And while doing the linearity test, we're gonna test for multicollinearity as well. So this dependent variable should not be multicollinear. At the same time, there should be some degree of relationship among those dependent variables. So the correlation coefficient should be less than 0.9, but should be above 0.2. That's a preferable range. So we're gonna test the multivariate normality and the linearity and multicollinearity by creating scatter plot and calculating our Pearson correlation coefficient. So this should be coefficient. I'm sorry for that. Okay. So let's go ahead and do that. So I'm gonna go here. I'm gonna close this one here. I don't want to save this output. Let's go ahead and do that. So let's go ahead and again, I'm gonna split the file across 8 different groups. Okay. Now I'm gonna go. So we are testing here scatter plot. So we're gonna go to the legacy dialogues here, scatter or dot matrix here, matrix scatter here, define here, and our 2 independent variables are income 2 and education 2 here. Okay. And that should be it. We don't need to do anything else here because we already split the file across 8 different groups. So we say okay here. So basically it's going to go ahead and create a scatter plot for our dependent variables for across 8 different groups. So you can see that logically, this should be more elliptical here. So if it is elliptical, we can be pretty confident that it's more or less linear here. So, but this graph, if you look at it, this is pretty much very elliptical shape here. So binormal, multivariate normality or bivariate normality can be assumed here because we just have 2 variables. At the same time, they looks like very linear here. So that should be tested across each group here. That's another way to look at it. Some of them have very small sample sizes, like only 10. So that needs to be considered thoroughly. And once you check the scatter plot, which here looks pretty decent for every cell, the next thing is I would like to go ahead and create the bivariate correlation across my 2 dependent variables, which is education here, income and education. And I'm going to see the Pearson, let's see here. Okay, here. So here you can see that, you can check for every group, for every cell, for 8 groups, we're going to check the correlation. So for example, here for male who are very satisfied, the correlation between our income and education is 0.33. So again, this should not be very highly multicollinear, like, you know, it cannot be, should be less than 0.9. But at the same time, we do expect some degree of relationship across this dependent variable, because they are sort of trying to measure the same construct. So if they're trying to measure the same construct or same underlying structure in the research, then they should be to some degree related to each other. So they should be, it's always preferable that the periods of correlation is greater than 0.2 and less than 0.9. So here it looks okay. So again, we are doing it for every group here. So for male, we have 4 groups here. All of them are 0.5, 0.3. So it looks very decent here. Okay, so here also it looks very decent here, all within the range. So this is how you should visually test the bivariate normality and linearity, and also via correlation coefficient here. This is how you should be done. Now I'm going to show you how the book does it. I'm going to do the data splitting off. Okay, so we have done that one off. Now if you go to the graph here, legacy dialog box, scatter plot is going to be the same, for example. So I'm going to show you still how you do that, but I've also seen people not defining any groups here, just doing between the two here. But logically you should be defining the labels as well, because it should be done for each and every label. So when you define the label, basically it's going to go ahead and create all those 8 different groups by bivariate correlations or scatter plots. So sex here and job satisfaction here. Say okay here. So it's going to create 8 scatter plots, right? And which are very similar to this one. These are much bigger. You can also, they are exactly same, but you can also customize this one to show bigger, but they are showing the same thing, so we don't need to worry about that. So this is how you're gonna do it as per the book. And now book says that you have to go to analyze and let's say calculate the correlation, bivariate correlation. Books just does it like this. Okay, so we're just going to calculate the bivariate correlation here. Say okay here. So there's a correlation of 0.337 between the two independent variables. We are not dividing this across 8 groups. We are just checking for the entire data set among these 2 dependent interval scale variable, the correlation coefficient, which is 0.337. This is another way to do it, but logically you should be testing for every group like I have shown you earlier. So this is how you should check for the missing values, the outlier, the sample sizes, the normality assumptions, and the linearity assumption as well. So with this brief description here, I would like to stop the video. I'm gonna again browse through this slowly so that you can pause the video and read all these assumptions in detail. It has a lot of useful information which can help you understand the statistical analysis better. So with this, I'm going to stop my video here. Thank you very much for listening.